So here's a lesson on using completing the square to actually solve quadratic equations using the square root method. But it's taken one step further. In lesson 4.5 you solved quadratic equations in this form where you had no bx using the square roots. But you can also use the square root method if one side of your equation is a perfect square trinomial. I'll show you what I mean. Here's an example down here. I have x squared plus 20x plus 100 equals 81. If I took this left side and factored it, noticing it was a perfect square trinomial, it would factor into x plus 10 and x plus 10, and that equals 81. Well, we know we can write that x plus 10 with an exponent because it's a repeated multiplication. So I really get x plus 10, that whole thing squared, equaling 81. Well, in order to solve it now using the square root method, you would just square root both sides, isolating this to x plus 10 and getting plus or minus the square root of 81 on the right side, which was just 9. And so you have an equation here, two equations really. You have x plus 10 equals 9, and you have x plus 10 equals a negative 9. So in order to solve for x, you just solve for them separately here. You get x is a negative 1, and x is a negative 19. Actually, I should say or, not necessarily and, so we'll say or in there. But the key was you started off with a perfect square trinomial, and then you could factor it into a binomial that was squared and use the square root method. However, in example 1, this was a perfect square trinomial. Sometimes you don't have expressions that are perfect square trinomials. For example, you might have x squared plus bx. Well, there's something we can add to this that actually makes it a perfect square. And this process of doing that is called completing the square, and it's what we're going to learn right now. This diagram here makes it look perhaps far more complicated than it really is. In order to complete the square for an expression that looks like x squared plus bx, here's what you're going to do. You're going to add to this binomial expression a third term that takes your coefficient of b and divides it by 2 and then squares it. And you'll see when we do this, we end up with a perfect square trinomial. So I'm just going to kind of skip ahead of all these diagrams here, and we'll just look down here at example 2. And it says that we need to find the value of c in this expression. We need to find this number here that makes this a perfect square trinomial, and then we'll write the expression as a square of a binomial. So I'm going to write down the steps that you're always going to follow to write a perfect square trinomial. So step 1 is to find half the coefficient of x. So I'm going to write that down. So here are the steps written down, and I'm going to walk through this example specifically in doing it. So it says step 1, you need to find half the coefficient of x. Well, what is half the coefficient of x? I need to know what half of 16 is, and I'll write it out long for your notes. And that is that we're going to, for this one, take 16 and divide it by 2 and see that that is 8. Step 2 then says take the number from step 1 and square it. Well, what would 8 squared be? Well, that's 64. So I'll just write that down. So now we're at the number of 64. And then it says to replace c in the expression above with the result of step 2, which was 64. So now my polynomial or trinomial will read x squared plus 16x plus, and I'll color that 64 in red so you know that that is the number that we added in order to make it a perfect square trinomial. So notice you have a 1 here, which is a perfect square, and a 64 there, which is a perfect square. So I could actually factor this thing into two binomials that were identical, and they would be x plus 8 and x plus 8, which we could write as x plus 8 squared, and eventually we'll use this form of it in order to use our square root method of solving. This was just an example here of how to make a trinomial a perfect square trinomial, or I should say, yeah, make a binomial a perfect square trinomial. But when you see us use it to actually solve the quadratic, it'll make a lot more sense. I'll do one more example though with you before I set you off to finding these things by yourself. So let's look at another example. Here we're asked to find the value of c that makes x squared minus 20x plus c, a perfect square trinomial. And I'm going to write down the shortcut rule, which was to take your coefficient of b, divide it by 2, and then square it. So if I took step 1, that would be to write down the coefficient of b, which was a negative 6, and then I was told to divide it by 2, so that would be 13. Sorry, negative 13. And then step 2 said to square that. So you would take negative 13 and square it and get 169. And then step 3 said to plug that in for c, or substitute it in. So our new trinomial would read x squared minus 26x plus 169. And we can write that as the square of a trinomial, meaning I would factor it right now into the two binomials that it would factor into because they're perfect squares. So that would be x minus 13 and x minus 13. And then written as the square, it would be x minus 13 squared. And that's an important part. So, we're going to look at the guided practice here. Some of these go back to example number 1. 1 through 3 are like example 1, where they're asking you to solve the equation by finding its square roots. And then 4 through 6 ask us to complete the square. And then moving on to example 3, we're going to put the two ideas together. So let's review example 1 there. And we're going to find the binomials that factor this perfect square trinomial. So it's important to notice this is a perfect square trinomial, and it came, or it can be factored into x plus 3 squared. I would just write x plus 3 and x plus 3 to factor that, and that's 36. And then to solve it, you would square root both sides and end up with x plus 3 equals 6 plus or minus 6. Remember, there's two equations there. And then when you said x plus 3 equals a positive 6, you 3, and x would equal a negative 9. All right, in the next example I want you to do alone. That's a perfect square trinomial already, so go ahead and solve that using the square root method. Pause the video. And there are your answers for 2 and 3. And what I'll say is the number one mistake kids tend to make is forgetting that there are two numbers here that you get when you square root a number. Like 36, you get plus or minus 6. The square root of 1 is plus or minus 1. Options for your roots. And for the roots of 100, it could be positive or negative 10. So if you forget that there's two solutions there, you're going to forget that there's two solutions there. So keep that in mind and remember that. All right, number 4 then is working on finding or creating the perfect square trinomial. So I will do number 4 with you, and then you can do 5 and 6 on your own. So step 1 was to take b and take half of it. So 14 divided by 2 is 7, and then you're supposed to take that answer and square it. And 7 squared is 49. That means I'm going to put 49 in for c. And so I'll just rewrite the expression as x squared plus 14x plus 49. And then they're always going to ask you to write the expression as the square of a binomial. So you got to get that binomial out of there and square it. Well, what binomial would I have gotten when I factored this? It would be x plus 7. And that is the binomial being squared. So we're answering the question. You do 5 and 6. Remember, your job is to take the letter b, or the number for b, divide it in half, and then square it, and that's simply c. So pause the video. All right, here's the answer for number 5, and I kind of left number 6 halfway undone. I don't know if you panicked because there was a fraction involved there, but to find c, you took half of a negative 9, and your job was to square it. So don't panic over that. You just don't turn it into a decimal. So when you square a negative 9, you get 81. And squaring a 2, you get 4, and you throw that in for c. Now maybe you panicked when it was time to break it into the binomials, but don't do that either, because you know how to do this. I'll do it as two binomials first. You just square the first term. So the square of 1 is, or x squared is just x. You know that your signs are both negative, and now you need to just square root the last term. So the square root of 81/4 is just 9/2 for both spots. And then you put them together to write them as a square of a binomial. So just don't panic when you see fractions, because it's really not that hard when you see it. So now let's put these two concepts together and actually solve equations using the completing the square method. You can do this for any quadratic equation. When you complete a square as part of solving an equation, the key now is to add that C number that you always found to both sides. That's just the golden rule of algebra. Whatever you do to one side, you have to do to the other. So we're going to show you how to do this with example 3. And here it says x squared minus 10x plus 1 equals 0, and they're specifically asking us to use the completing the square method. Remember, the key was we always had a binomial, the x squared minus 10, and then c would be inserted in. So I actually need to remove this 1 and get it over onto the other side, because I need to complete the square based on these first two terms of the standard quadratic. So I'm going to have x squared minus 10x equals a negative 1, and I'm actually going to erase this and leave a space because I'm going to put my number c in there. So I have the negative 1 written over here, and I wrote this here with two lines because whenever I complete the square, whatever c is, and I'm going to insert in here, I have to also do to the right hand side. So here we go. Let's find out what c is supposed to be. And the rule is, and I'll just write this off to the side, is you take half of b and then square it. So half negative 10 divided by 2 is a negative 5, and when I square that I get a positive 25. So that 25 is the number that's required to make this a factor into a binomial that's squared. So if I add 25 to the right side, or sorry, the left side, I have to also add it to the left side, right side. Sorry, my left and my right. The key with that is that's just the golden rule of algebra. Whatever we do to one side, we do to the other. So now we're back to like example 1, where I need to write this as a square of a binomial. So this is a perfect square trinomial, which means it will factor into the square of a binomial. And I'm going to end up with 24 on this side. So you square root the first term and you square root the last term, and this will have a negative sign in it because of that negative 10. So there it is factored, and now hopefully you should recognize that it looks like a problem that we can just use the square root method to solve it, and it becomes quite straightforward. So when I square root the left side, I get x plus 5, and when I square root the right side, I get plus or minus the square root of 24. So I need to reduce that. It's not in simplest form, but I think I'll add 5 to both sides first because I'm solving for x. I get 5 is plus or minus the square root of 24, and hopefully you see there is an 8 in here. There's also a 4 in there. I'm going to use 6 times 4 to simplify that radical, and so I get x equals 5 plus or minus, and let's see, that would be 4 times 6, so I'm going to get 2 times the square root of 6 as my simplified answer using this completing the square method. You may want to jump to the guided practice problems now. If you want to practice example 3, example 4 takes it one step further, and they show us a problem where we have a quadratic here, but we do not have 1 as a coefficient there. And you really want a 1 as a coefficient here. And so what you do in this situation is just divide everything by 3 to begin with. So I'm going to divide by 3, and that's going to give me x squared minus 12x plus 50 equaling 0. 0 divided by 3 is just 0. So now you are in the basic completing the square kind of situation. Again, I don't want that 50 here because this is not a perfect square trinomial. So I'm going to subtract 50, get it over to that side. You have x squared minus 12x plus some number, which we're going to find, equals a negative 50 plus that same number to follow the golden rule of algebra of keeping my equation actually equal. So now I need to find the number that's going to go in the blank spot. You take the b term, which is 12, you divide it by 2, and then you square it. So negative 12 divided by 2 is a negative 6. That thing squared is a 36. So I'm going to put a 36 on the left side, which means I have to put a 36 on the right side. Then you factor that perfect square trinomial, which means you're going to have a binomial that's squared, and over here you'll have a negative 14. So square root the first term there, and you get x, and you square root the last term, 36, and you get a 6, and it has to be negative because of that minus 12. And now you just use the square root method, square root the left side and the right side. You're left with x minus 6 equals plus or minus the square root of a negative 14. Well, what? Look at that. We have complex numbers coming in no time. And so let's just rewrite this. X minus 6 equals plus or minus, and I'm going to get rid of that negative square root immediately by realizing that I is the negative square root of 1. So I will put an I on the outside and 14 still left in the radical. And then finish up by adding 6 to both sides. And there is your complex answer for what x equals. I know it's tough. We'll do some guided practice together. So let's begin our guided practice section where you do 7 through 9 on your own. 7 through 9 are just completing the square, making it a perfect square trinomial kind of problem. So for number 7, remember, you need to take that negative 4 and move it over to the right side. Same thing with number 8. And number 9, you're going to need to divide by 2 first. So pause the video now and go ahead and solve 7 through 9 and then come back. Alright, and here are your answers. I worked out number 7 mostly. I just skipped a little bit at the end there in the blue. The answers for number 8 and 9 there are there as well. Remember to ask questions. Oops, I noticed I didn't have a minus sign here. That needs to have a minus sign for number 9 as well. Okay, number 10 is the same as number 9, where you need to divide by 3 first. So go ahead and do that. Pause the video and come back for that answer. And here's that answer written out. Alright, number 11 and 12, you could actually solve right now quite easily. Actually, you can't. I thought they were equal to 0, so you can't. So what you need to do for 11 and 12 is to distribute the term on the outside of the parentheses and make it quadratic. So, for example, number 11, you would multiply that 6x through to get 6x squared plus 48x equals 12. And now you need to divide by 6 in order to simplify it. You only want to complete the square. You have to get a perfect square in the first term, so it needs to be a 1. So divide everything by 6 and you get x squared plus 8x equals 2. And then now go ahead and complete the square on that one. And so you will have x squared plus 8x plus some number equals 2 plus that same number. I'm going to pause it now. You pause it and finish up the problem on your own. And then move on to number 12. You can do that one now, too. And there is your answer, or the solution for 12. All right, well, we're going to move off on a little tangent, although it still involves completing the square. And that is the idea of vertex form. If you remember in lesson 4.2, you learned that vertex form of a quadratic looks like this. Well, if we're given an equation in standard form, now that we know completing the square, we can change it from standard form into vertex form. But again, we're using completing the square. So let's start off working on this example number 6. All right, so here it gives us an equation in standard form, y equals x squared minus 10x plus 22. Well, to begin writing it in vertex form, we need to begin completing the form, or completing the square on this part of the equation. And so I have my left side, which I'm going to add some number, which is that c we're always looking at. And I'm going to write this as the start of my perfect square trinomial, knowing that I'm going to put some letter c in there. And I'm going to leave the 22 on this side for now. All right, so the only thing I did was get ready to add the number that will complete this trinomial and make it a perfect square. So the same idea holds. I need to find this number, so I'm going to take b, which is negative 10, take half of it, which is negative 5, and then square it to get 25. And if I do it to the right side, I have to do it to the left side. That's why we made space for it over there. So now you have that equation written down. The next step is to take this perfect square trinomial and factor it into the square of a binomial. So on the right side, you still have, left side, y plus 25. And on the right side, when I square that and make it a binomial, I get x minus 5. Actually, I'm square rooting it. Sorry, I'm factoring it. So I get x minus 5, and I'm squaring it. Now, I'm going to remove this 25 from this side so I can solve it for y. And so when I subtract 25, I leave this squared binomial there, and I take 22 minus 25, which is a negative 3. And this should all of a sudden look really familiar to you because you just created the vertex form of this original quadratic in standard form. And remember, the vertex form is special because your vertex comes right out of it. So our vertex of this equation is 5 and a negative 3. So if you just kind of follow that pattern and think about it logically, you won't have too much trouble in doing these problems. I'm going to skip this example 7 for now. I'll do it later on in another video when we really work on that vertical motion model again. Here you can see you have that vertical motion model, the negative 16 being the acceleration due to gravity. But I'm going to move right on to guided practice so we can get used to doing this more. So let's do guided practice number 13 together, and then I'll leave you to do 14 on your own. But this is the granddaddy of them all. If you can take a quadratic equation that is in standard form and convert it into vertex form, you have really learned what you were supposed to learn for this section. So let's start off. We have the quadratic y equals x squared minus 8x plus 17. And remember, we're going to complete the square on this part of the equation. And so I will write y plus some number is equal to x squared minus 8x plus whatever number completes this square plus 17. So what number completes that square? You take negative 8 and divide it by 2, which is negative 4, and then square that, which is 16. So if I add 16 to the right side, I need to add 16 to the left side. Now we will write this as, we'll take this perfect square trinomial and write it as the square of the binomial that it factors into. So you will have x minus 4 there, and then that's 17 at the end there. And now your next job is just to remove that 16 from both sides, and so you end up with y equals x minus 4 squared plus 1, which is now vertex form. And your vertex, we'll just write down because it's good practice, is 4 and 1. All right, you do number 14, pause the video and follow example 13 and come back when you're ready. Pause the video. And there's your answer.